Okay, dear student, let us see what is there in this question. Potassium-40 decays by two processes. The first process is that of the beta minus decay to form calcium nuclide. Write down the equation for this decay. Okay, so the equation will be, this is the potassium 40, this is 19, and beta minus is coming. So this is calcium, and in beta minus nothing happens to the mass number, so beta minus can be written as minus 10. So because this is minus 1 here, it means that the atomic mass number will increase by 1, and although you must be even remembering that in beta minus decay the atomic number increases by 1, so this atomic number will become 20. Now along with that, whenever there is an electron you have antineutrino. Always remember it. Like it's a thumb rule. And you can remember it like this. Electron is negatively charged. So whenever electron is released, there is a neutrino having a bar on its head. Just to remember. And there is no other option. It will always happen like that. So if there is an electron, there will be an antineutrino and the charge is like 0, mass number is 0. This is it. This is the reaction that is taking place here. Well, another thing is you can note it, the mass number is increasing. So this is actually what is happening inside the nucleus. This is what happens inside the nucleus. Overall, it looks like this. Clear? So this is the answer that you were supposed to give. This one, not this one. Okay, this one is the correct answer. And let us move to the next question, and we will see the mark scheme later. Potassium-40 decays by a second process to argon-40. This decay accounts for 11% of the total decays. Rocks can be dated by measuring the quantity of argon-40 trapped in them. One of the rock sample contains 340 micromole of potassium and 12 micromole of argon. Show that the initial quantity of the potassium-40 in the rock sample was about 450 micromole. Okay, so we can just assume that the potassium-40 is converted into argon-40 with some various reaction that was taking place. We don't even care about that. One thing is clear, one atom of potassium is converted into one atom of argon. It means that number of moles of argon, like 12 micromole, that should be same as that of the potassium which underwent the disintegration. It means 12 micromole of potassium-40 went disintegration, but it says that argon will be created only 11% of the sample, by only 11% of the sample. It means 11% of the total number, let's say, which are like disintegrating, 11% will be able to create the argon, so that will be equal to 12 micromole, which means that the number of the potassium atoms which have actually undergone the disintegration, that can be found by using this formula. So we can keep our answer in micromole, so I'm not taking micro there. So accordingly, that will come out to be 1200 divided by 11 micromole, and we need to find the answer for this. 109. So this is coming out to be 109 micromole. It means 109 micromole of potassium, it underwent the disintegration. Okay, out of this, 11% of the potassium disintegrations, they created argon, which comes out to be 12 micromole. So this much was earlier present. 340 micromole of potassium is present even now. So what was the initial number with which you started? It will be 340 plus 109. So that will become 449 micromole, which is approximately equal to 450 micromoles. So this is how we do this. This is the proper explanation of this question. Is it clear? I think this should be. If there is any other doubt, you can ask in the comment section. Let us see what is done in the mark scheme. Is the answer correct or not? Yes, here. So the total potassium 40 decade is 109, and they have just added 1090 to 340 just like we did, and they are getting the same answer, that is 449 micromole. So this is how we do this. This is the proper explanation. Now let us go for the next question. The half life of potassium 40 is this: estimate the age of the rock sample. So half life is given and estimate the age of the rock sample. So we have to use the earlier data now. So you started with the 450 micromole, and half life is this: estimate the age. Yeah. So this much of the potassium is left. You started with 449 exactly. So we will say we will use this formula for this: T divided by T half. Number of moles which are left in the sample is 340 micromole. So this will be 340 micromole and micromole, because you are having the same units on both of the sides, they can cancel each other out. 340, yes. And you started your reaction with 450, half T divided by T half, which is given here. So we would be using the logarithm now, and by using your calculator, you can clearly find this. With the help of logarithm, I mean to say 34 divided by 45 is equal to half raised to power t divided by t half. You take log on both sides. Yeah, like this. Okay, because this is the power, the exponent, that will be multiplied with the logarithm later, like logarithm of 1 by 2. By using this equation, t half value is given to you. You substitute this value here, and we can find t. So for this, I'm not using the calculator now. It would be taking time. You people can find this answer by yourself. Let us go to the mark scheme and see if they have done the same thing. Yes. So this is a different alternative. This is again, yes, this is what we have done. uh ln2, yeah, yeah, yeah. Okay, this is alternative 3, sorry. Alternative 3 is what we did. 340 divided by 449 is coming out to be 0.76, is equal to half raised to power t divided by t half. So this is what I have employed. This method is like most suitable and best suitable method. In paper 1 you would be getting the questions that you would be getting, they would be based only on this formula. This formula becomes very important for us. So the answer for us is 5.2 into 10 raised to power 8, and this is how we do this question. Let's see if the question is over. No, there is one more part. Let's go for this. Okay, see. Outline how the decay constant of potassium 40 was determined in the laboratory for the pure sample of nuclide. So how can you find the lambda, that is the decay constant? See, whenever you talk about the laboratories, the only thing that we have in our syllabus which is related with this is the activity. So the count rate, that you know it better. So activity of a sample is related with the number of moles, like this, like number of particles here. So we can say that we will first find the mass of the sample, then we can find the n, like number of atoms or like number of moles and whatever. To be specific, it has to be number of atoms, like literally the number when you multiply with the Avogadro number, like that. And activity you can measure with the help of your instruments. So activity, the unit will be becquerel, and you can measure it with the device. And from there you can find the lambda, that will be a divided by n. So n will be like the initial amount of substance that is available. You can find the value of n there, and from the device you can find the instantaneous value of the activity, and by dividing these two you would be getting the decay constant. This is the only suitable method I can suggest here, because this is the only thing that is in our syllabus. Other methods might be there, but they are not in our syllabus. I hope this will be the thing that is given in the mark scheme. Let's see. And yes, this is the answer that is given. Use the mass of the sample to determine the number of potassium-40 atoms. Use the counter to determine the radioactivity sample. Counter means like the count rate. We will use that, and then you use A is equal to lambda n, and accordingly you can find the value of lambda. So this is how we do this question, and I believe this is the last part for this question paper. Yes, so this question paper is also over. All of the questions have been uploaded on the YouTube channel. Thanks for joining. Please watch all the videos and share the videos with all your friends. All the best. Bye.